Today's webinar is entitled VSC Technology for the Detection of Fraudulent and Counterfeit Documents. Okay, welcome to the webinar. My name is Nicholas Crabb, Regional Sales Manager, Foster & Freeman. Now, as always, to simplify proceedings, all guests are muted. Please use the chat box to ask questions on the right-hand side of your screen, and we will endeavour to answer as many questions at the end of the webinar. We're really grateful to you for choosing to spend an hour of your time with us this morning, and we hope that you will find the content of today's webinar both interesting and informative. As with all of our webinars, and in fact there's been over 20 this year so far, it is our aim to provide you with an insight into the world of forensics. We will also demonstrate some of the latest techniques and technologies available to forensic investigators for the detection and examination of criminal evidence. This week's webinar will focus on our specialist subject since the start of Foster & Freeman, the VSC, or Video Spectral Comparison Technology, for the examination of questioned documents. Used by document examiners around the world since 1979, the Foster & Freeman VSC instruments are widely considered to be the #1 technology for the forensic level examination of any document that's origin or integrity is in question. Let's have a look at some of the early VSC instruments and see how the product has evolved over the past 41 years. As you've just seen, there are plenty of changes to the VSC system over the years, some obvious, the addition of an external PC, for example, and some are a little harder to spot in the software or under the hood. Key to success and longevity of the VSC is the way in which our R&D and software engineers have continually updated and improved upon the technology. This is vital that our VSC instruments continue to evolve in order to keep pace with the type of documents that examiners are asked to analyse and to stay ahead of the technology that is employed by professional fraudsters. Now, in the early days, VSC instruments were purchased exclusively by police and forensic labs for use by dedicated question document examiners. These labs would often be looking at a large number of handwritten documents in the main, investigating proof of provenance or looking for evidence of alterations, altered signatures, changed numbers on cheques, and so forth. As the technology became better known, universities and museums began interested in VSC systems for the examination of ancient manuscripts or documents, old documents. In fact, we only ever manufactured one VSC2, which was purchased by the British Library, who used it to reveal previously unseen sections within the original Beowulf manuscript. Later, we sold a great many VSCs to other industries, for example the insurance companies, for use by their in-house fraud prevention teams to look at fraudulent insurance claims. Nowadays, VSC instruments are widely used across a multitude of industries, including security printing, printers checking the quality of their own secure documents, lottery companies who use VSCs to authenticate winning tickets and develop security features for tickets, pharmaceutical manufacturers analysing counterfeit packaging on their products, and even stamp collectors or philatelists validating authenticity of high-value stamps and collectibles. But for the past 15 to 20 years, by far one of the biggest user of VSC technology has been the immigration market. Used at air, land and sea ports, at border crossings and immigration centres, VSC instruments are the final word in travel and identity document authentication. Now, the reasons for this are mainly twofold. Firstly, countries across the world are tightening their borders in the face of mass migration, whether legal or illegal. And secondly, identity documents, passports in particular, are high-value items that are constantly targeted by criminal gangs and professional fraudsters. With the increasing use of fraudulent and counterfeit passports has been described as an epidemic, with the estimated number of fake passports in issue growing exponentially year on year. So, how do we fight back against fake passports? With a V, a C of course. The current range of VSCs include a wide selection of hardware and software tools for the interrogation of passports. From multispectral examination of inks and paper substrates to the forensic analysis of embedded biometric chips, e-passports. In a moment, Dan is going to take us through a selection of documents explaining how we can use a VSC to identify fakes and reveal evidence of tampering. Now, before that, let's just have a quick look at some of the most common methods of passport forgery that we can expect a document examiner to encounter in his day-to-day work. The first one, obviously, impersonation, where an individual uses a genuine passport that actually is not their own. Using a VSC equipped with the facial identification module, we can compare the printed photograph against the image stored on the document e-chip against a live image of the individual captured via a webcam. The system then is far more accurate than a subjective human being and eliminates the threat of a lookalike passport fraudster. Second, a complete reproduction starting from scratch to resemble an officially issued document. This is usually a high level of counterfeiting performed by criminal gangs with access to cutting-edge printing equipment. Here the differences between fake and genuine are found to be minute. The VSC is well equipped in the department, providing all the examination tools for the examiner, including high magnification imaging and a spectrometer for advanced colour analysis. Thirdly, the third type of fraud is forgery. A genuine document has been altered in some way, for example, substituting a biometric page, a photograph, altering the personal or biometric details. Again, A VSC is well equipped to examine the fine details of these documents, while the original VSC function, multi-spectral analysis from UV to IR, can reveal the use of different inks on a single document. Fourthly, and finally, we have a pseudo or fantasy document. These are documents that may have the physical appearance of a genuine document, but are not officially recognised. Faced with such a document, an examiner may use the VSC to access the Keysync Security Documents database that we have available as an optional extra via a subscription with all VSCs. Now, while searching this database, the examiner can determine whether or not the document has ever been officially issued, i.e. whether it's fake or real. Okay, so now you know what you're looking for. Let's pass over to Dan and see how he goes about examining a selection of suspect documents.
So the first document we have here is everyone's favourite document, the infamous Italian ID card. And if we have a look on the front cover page, we have an example of an alteration on the identity card number. So here, if we zoom in, it's fairly obvious visibly that there's been an alteration, but there are a few ways that we can check this and also identify what the original number was as well. So if we have a look at the side lights first, we have an example here of mechanical erasure where parts, presumably of the number 4, part has been removed to turn this into a 1. And if we go back to normal visible lights, again, we can see where an actual physical pen has been used rather than the letterpress printing that's traditionally used. And if we just use a fairly high camera filter and just refocus that, you can see where this pen actually starts to drop out and react completely differently to the original ink. On the inside of this document, we also have evidence of photo substitution. So here we can see cut marks where the original photograph has been removed. And normally when this document is made, a dry stamp is applied to the photograph, which will also appear on the paper document as well. But if we use the side lights, not only can we see the cut marks even more, we can see visibly the stamp on the photograph itself, but a complete lack of this stamp on the actual paper document itself. And here we would expect to see that stamp overrunning onto the paper. So the fact that this is missing is a clear indication that this is not the original photo that was present in this document. Our second example, we have 2 Lithuanian driving licenses, one genuine, our specimen, and the other which is our suspected counterfeit. If we have a look at the genuine document first, and just this area here is a good example of the quality of printing and the type of printing that you would expect in genuine documents. And if I capture this and compare this to our suspect document, you can immediately see it looks even that printed, it looks as though the image is out of focus, but it is in focus. Even the little kind of hairs on the document here are indicating that. But you can clearly see the difference in quality of the printing between the 2 documents. And this is one of the most common giveaways of the more basic counterfeits. It's just the general quality of the printing. And we only need to see this using higher magnification within the VSCs. So another common feature that's present in almost all identity documents is UV. So it's incredibly common. And here we see the reverse of the genuine document. So we have a UV feature of the car at the bottom, but also the lack of reaction from the actual document itself. So it's UV dull. If we swap that and then have a look at our counterfeit document, we can see that the entire card is fluorescing. We do have an outline of this car itself at the bottom. So a very basic imitation of the UV reaction, but still completely different to how the genuine document should react, and a very easy giveaway that this is not a genuine document. In this example, we're looking at a British driver's license this time, the reverse side of the genuine document, and here we can see the UV feature under 365 nanometer UV. We can also clarify this or confirm this by looking up this document in the database. So if I was to look up the correct entry in the database and then look at the reverse side, we can see that we have the same feature. However, if we compare this to our counterfeit document, so interestingly, we do have what appears to be quite a nice UV reaction, but it is completely the wrong reaction for this type of document. Again, also comparing this to the original document, the card itself has a faint reaction, which again you would not associate as the genuine documents are UV dull. So this comparison in the same shot quite clearly demonstrates the different UV features and also the different reaction within the laminate or the actual card itself compared to the genuine, which is at the bottom. On the front of the UK driving licence, there is also the presence of these tactile features within the laminate. So you may just about see these on the image here, but the best light source for viewing these is actually a light source that's designed for another feature, which is a coaxial light source. So this light source is predominantly designed for looking at the retroreflective laminates within some passports and ID cards. But here we're able to see these tactile features within the laminate very, very clearly. And again, if we compare this to our counterfeit document, you can see actually this document does have these tactile features and it is reacting in a similar way. But again, comparing to the genuine, the quality of the counterfeit is much poorer and is lacking the printing or the text that the genuine document has. So again, this is another very easy comparison between our genuine and our counterfeit document. So if we compare the UV features on the front side of this driving license, again, if we have our genuine document at the bottom and our suspect document at the top, again, we can see that it does have UV features, but they are not what we'd expect for this series of document. And again, you can see the difference in the kind of base UV reaction of the card and the laminate itself. In this example, we have a comparison between two passports. So firstly, we can have a look at our genuine or our specimen document. And this is a good example of where we can use the quartz plate as opposed to using the document weights to keep the document nice and flat without having the weights overlapping or covering up parts of our document. And the other benefits of the quartz plate is that it allows full transmission of UV light, whereas conventional glass will not, particularly at the shorter wavelengths. So this is the document under 365, this is our specimen document, and then if we compare that to so this is the document under 365 nanometer wavelength UV, and if we compare that to our counterfeit document, we see this. So this is our counterfeit document. The page on the left is completely fine, as is the rest of the document, as it is only the biodata page that has been substituted. And we can see the complete lack of any ultraviolet features. And again, the page is fluorescing slightly, which again, we would not expect from the UV dull paper involved. In this example, it's worth pointing out one feature that counterfeiters too often struggle with across all types of documents, and this is OVI, or optically variable ink. So here we see the color that we would normally see, this kind of more gold color, but then if we physically change the angle of the document when we're viewing it, it changes to this more green color. But it's obviously very difficult to move the document in the VSC, so to replicate that we use this mirror, and this is an excellent way of simultaneously seeing the two different colors of the OVI. Once again, if we compare that to our counterfeit document, we can see a complete lack of this feature, as well as again the much general poorer quality of the printing involved as well. So again, this is a very easy test for the lack of this feature on the passport. Here we have an example of a bank money transfer document, and in this particular example we're focusing in on the amount, in this case the first three numbers of this amount, which in this case says 644,000 euros. So a substantial amount, but we believe that this has been altered, and in this case, if we use the spotlight, already we can start to see some evidence of an alteration or potentially multiple inks. And in this particular case, we can see that the 6, there is a number behind which is looking quite different. It looks more indicative of the number 1. We can also see evidence of inks behind the characters here as well, but they look to be the same number. So this might be an example where this entire document has been either bleached or the ink has been physically removed, and these numbers have just been simply rewritten on top. But instead of a 1, this first digit has been changed to a 6, so from 144,000 to 644,000. So this is a very good example where we can use the spotlight to still see the fluorescence of inks that have been removed and cannot visibly seen under normal lighting. So here we have no indication of any original ink, and if we use side lighting, there is no indication of any physical alteration, but again, you can still see here a shadow from this, what would be indicating of the number 1, which again you would not expect if this was just written with the number 6. Using the side light, we highlighted the possible location of the original number 1. So we could take this a step further and examine this under 3D. So we can see here the original colors of the document, but if I now change this to this here, we can now again start to see evidence of this original number here, as well as other areas here, which again seem to indicate or confirm that this is the number 4 that's just simply been rewritten over at the top. But we definitely have an anomaly here within this first character of the 1 being changed into a 6.
Thank you for that, Dan. As you've seen, there is no one way to detect a fake document, and a VSC user can be required to utilise a wide variety of techniques to identify counterfeits and forgeries. In some cases, the very latest technologies, 3D imaging, facial recognition, etc., are required to authenticate documents, while in other cases, time-honoured techniques such as infrared imaging remain even 40 years since they were first introduced, the best method to detect evidence of tampering. Today, our latest model, the VSC 8000HS, is the world's most advanced VSC workstation, providing an unrivaled suite of examination tools for the interrogation of all question documents, from ancient manuscripts through to the latest generation of e-passports, ID cards, etc. But document examination is always evolving, and as for passport printers come up with new and advanced security features, and fraudsters come up with new ways to produce near perfect fakes, our VSC range will continue to evolve, as it has over the last 40 plus years, to remain one step ahead of the fraudsters. Thank you for listening. Now we move over any questions.